Hi everyone. Today's note is called the corner point method. Today's note is a longer note, so please make sure that you go through it with enough time that you can practice all of the skills and that you have a good understanding of what's going on, because it's getting very involving now. You're going to need at least 4 or 5 different colors today, so please make sure that you have those ready before you start the note. Last class we discussed how to sketch a pair of simultaneous linear inequations. Well, now we're going to graph several more and then find an entire region that remains unshaded, otherwise known as the solution region. So here is the example that I'm going to start with. I've got 4 inequations. So I've broken it down into 4 steps, and I'm going to use 4 different colors. So for now, number 1 is in black, number 2 in red, number 3 in blue, and number 4 in green. So here it says sketch the graph of x is equal to 0. Again, this is a vertical line. And because it has the greater than or equal to, it's a solid line. So I want everybody to go to the graph on the next page. Graph the line, shade, use a test point and shade in the unwanted region. So if I go over here, this actually happens to be the y-axis. So it's right here. It's this whole line right here. And I'm going to pick a test point. Notice I've given you this chart below. So I'm going to pick my test point. And a good test point, let's say, for example, is 1, 1. So that's 1 is greater than or equal to 0. Well, that's true. So I want to shade everything to the left of this line over here. Okay. Next, for me in red, y is greater than or equal to 2. This is a horizontal line. Because it has the greater than or equal to, again, I'm going to use the solid line. I'm going to go to my graph, and y equals 2 is here. I'm going to pick a test point. My test point, let's say, is 0, 0. So 0 is greater than or equal to 2. Well, that's false, so now I'm shading everything below the line. So hopefully you notice I'm taking out entire chunks of the graph. So look at what's left. For me now, I'm using the color blue. So it says here I want to sketch this graph. Y is less than or equal to negative a half x plus 10. I'm going to use the slope y-intercept method. And I'm going to test a point and shade the unwanted region. So everybody go to your graph. My graph is here. I start at 10, which is up at the top. And I go down 1 and to the right 2, like such. It is, again, a solid line, so like this. And it should look like that. I'm going to pick another test point. My test point, again, I'm going to say is 0, 0. Here's a handy little test point one more time. 0 is less than or equal to 10. That's true. So I'm going to shade everything above the line. So I've taken out that area as well over there. All right, lastly, in green for me is this graph over here. Well, this graph isn't in y equals mx plus b form, but I'm going to put it into y equals mx plus b form in order to make my life a little bit easier. So I'm going to do it down here below. 3x minus y is less than or equal to 4. I'm going to, quote unquote, move y to the other side because it's negative here. And I don't want to leave the negative on this side. I want to move it to the other side. So I'm going to say 3x minus 4 is less than or equal to y. Well, that's one way to write it. Or I could simply change it around so that it looks better and I can say it a little bit better and say y is greater than or equal to 3x minus 4. Literally, all I did was read it this way instead of this way. So here we go. Y is greater than or equal to, I'm going to write it over here so that I can see it. Y is greater than or equal to 3x minus 4, just so that I can refer to it. So I'm going to start here at negative 4. And I'm going to graph in the rest of my lines. And it's, again, a solid line. So up 3 over 1, up 3 over 1, like that. Down 3, left 1, down 3, left 1. A solid line. Like this. And I'm now going to pick a test point. My test point, again, is my handy dandy 0, 0. That's 0 is less than or equal to 4. Well, again, that's true, so I want to shade everything, quote unquote, to the right or below the line. Hopefully you see this lovely unshaded region right here. So far nothing is really new to what you want to do, but now we want to label the corner points of the intersection of the polygon that we just highlighted here in yellow. So I'm going to label them A, I'll label this one B, I'm going to label this one C, and I'm going to label this one up here D. Now this one's really handy because my graph works really nicely and I can see all the points perfectly. This is the only example today where it's going to be like that. The other examples are going to be with decimals or fractions. This example is the only one that's going to have whole numbers in it. So notice that I've used different colors. It's going to really help me in the fact that I've used different colors to do the next part, which is outline here what's happening on my corner points. So notice my page is sideways, so you're going to hopefully change your work a little bit, and I'm going to turn my screen around. So my corner point A happens where this line x equals 0 meets this line y equals 2. So that's where x is equal to 0 and y is equal to 2. So corner point A happens at 0, 2. Well, that was pretty easy and straightforward. I can see that right here at 0, 2. Now B happens when the red line meets the green line. So the red line was easy. That's y is equal to 2. And the green line is 3x minus y is equal to 4. So I'm now going to do a little bit of algebra. I get 3x minus 2 is equal to 4. So 3x is equal to 6. So x comes out to be 2. That means corner point B happens at 2, 2. Again, if you look at your graph, that's where it is. Corner point C is where the green line meets the blue line. The green line, I know, is 3x minus y is equal to 4. And the blue line is y is equal to negative a half x plus 10. Again, I can use any system that I want, but substitution here works really well. So I get 3x minus a half x plus 10 is equal to 4. I get 3x plus a half x minus 10 is 4. That's 3.5x, or another way to say it is 7 over 2x is equal to 14. So 7x is 28. So x is 4. If x is 4, I can substitute that back in, and I get y is equal to negative a half times 4 plus 10, which is negative 2 plus 10, which is positive 8. So point C happens at 4, 8. If I look really carefully here on my graph, that's exactly where C happens. D happens where the blue line meets the black line. Well, the blue line is y is equal to negative a half x plus 10, and the black line is x is equal to 0. Well, if I know x is 0, That means y comes out to be 10. So corner point D is at 0, 10. Again, if you look at my graph, that's exactly what happened. So let's walk through the steps again. Step 1. Graph each line or each inequation and shade the unwanted region. Highlight the polygon or the unshaded region that's left. Label all the corners and then find the intersection points of the colored lines that meet. So here's this next one. This next one here has 5 different lines. Hopefully you've noticed that the first 2 right here basically take out all of the negative areas of the grid. So I'm going to do both of those in black. That might help my life a little bit easier. And then every other color. So for example, this one I'll do in red, this one I'll do in blue, and this one I'll do in green. So I'd like you to try it yourself. Everybody should be able to graph, pick a test point, and shade. Everybody should be able to do this first page on their own. So here we go. So for me, for black, x is equal to 0 is the y-axis. I'm going to pick my point to be 1, 1. So 1 is greater than or equal to 0. Well, that's true. So I'm going to shade everything to the left of the line here. I've got y is equal to 0. That's the x-axis. Again, I'm going to pick the point 1, 1. That's 1 is greater than or equal to 0. That's true. So again, I'm going to shade everything below the axis. So basically right now all I have is the positive quadrant here. Next for me in red, y is greater than or equal to a half x. Well, that goes through 0, 0 here and goes up 1 over 2 like this. It's a solid line. I'm going to pick a test point. This time my test point cannot be 0, 0 because it goes through that line. So again, I'm going to pick 1, 1 for the sake of making my life easier. That's 1 is greater than or equal to a half. That's true, so I'm going to shade below the line like that. Next for me in blue, I've got x plus y is less than or equal to 9. I can use my x-intercept and y-intercept, and I'll learn very quickly that it will hit here at 9, 0 and here at 0, 9. So if you need to do the work here for this one, I suggest using the x-intercept, which is 9, 0, and the y-intercept, which is 0, 9, to plot. When I do that, it's a solid line again, and I'm going to pick a point. My point here I'm going to pick is 0, 0. I get 0 is less than or equal to 9. Well, that is, again, true. So I'm going to shade everything above the line. Hopefully you're noticing that there's a shape here. And the last part in green. In green, I've got 8x minus 3y is less than or equal to 24. I recommend that you use the x-intercept and y-intercept. So if I'm using the x-intercept, y is 0, and I'm using the y-intercept, that's x is equal to 0. So I want to be able to figure that out. When I do, I get the x-intercept is 3, 0, and I get the y-intercept is 0, negative 8. So here, 3, 0, and 0, negative 8. So again, a solid line like this. And I want to pick my test point. Again, my test point, a great one, is 0, 0. I get 0 is less than or equal to 24. That one's true as well. So I'm going to shade this whole region, and notice that I actually get rid of that little sliver in there. Fantastic. I want to now highlight my polygon. So here, 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 and here. I'm going to label my corners. This is A, this is B, this is C, this is D. I want to now go through the corner point method. So A is where the two black lines meet. That was pretty easy. That's x is equal to 0 and y is equal to 0. So A is at 0, 0. That's handy. Corner point B, if I look at my graph, that's where the red line and the green line meet for me. So that's y is equal to a half x, and 8x minus 3y is equal to 24. I'm going to use substitution, and when I do, I get 8x minus 3, 8x minus 3 over 2x is 24. I get 13 over 2x is 20. Which I can also say is 24 over 13. So corner point B is at 48, 13. So that's x plus y is equal to 9, and 8x minus 3y. It says here, this is new. And finally, which one maximizes or minimizes. So everything stays the same. I do it the exact same way. I graph my line, I shade the unwanted region, I highlight my polygon, I pick corner points, I figure out algebraically what my corner points are, and then here's my new step. Is the equation that's to be maximized is this. I'm going to substitute in my corner points and see which one gives me the largest, i.e. the maximum value. So let's try it out. Here again I have 5 different equations. I'm going to make these two black. I'm going to make this one red. I'm going to make this one blue. I'm going to make this one green. For me, black. X 0. So I use my test point. I'm going to use 1, 1. So 1 is greater than or equal to 0. That's true. So I'm going to shade to the left of the line. Gone. I'm going to than or equal to 3. Solid line here. I'm going to pick 0, 0 equal to 3. Again, that's true, so I'm going to shade everything. I'm going to pick my point 0, 0. 0 is left. That's true, so I shade everything above the line. In green, I've got plus 2y is greater than or equal to 20. I'm going to use x-intercept and my y-intercept to solve this, or graph this, sorry. My x-intercept is something 0, and my y-intercept is 0 something. When I solve that, I get 4 and 0, 10. So 4, 0 in green is here, and 0, 10 is here. Again, another solid line. And when I pick my test point to be 0, 0, I get 0, I'm going to highlight my polygon that's here. I'm going to points. And this here is C. So A is where the blue line and red line meet. So the blue line is this. Easy. Corner point C is where the green line and the red line meet. So that's x equals 3. So my corner point C is 3, 5 over 2, otherwise known as which one, when I substitute in for x and y, gives me the largest number for z. So I want to sub in corner point A. So z is equal to negative 3 times 2 over 5 plus 9, which is comes out to be 7.8. Z is equal to negative 3 times 3 plus 9, which comes out to 0. And z is equal to negative 3 times 3 plus 5 over 2, which is negative 9 plus 5 over 2, which is negative 6.5. So right now, the corner point that gives the greatest value or maximizes the above equation is corner point A, which is 2 over 5, 9. So again, this was a longer note. I completely understand that, but the steps that I'm taking are the same every single time. 1, graph the line. 2, pick a test point. 3, shade the false region. 4, continue for all the other equations. 5, highlight the polygon. 6, label the corner points. 7, find the corner points algebraically. And now 8, substitute into the equation for z and figure out which corner point maximizes the equation. Give the homework a try. Make sure you take the time to do each of them properly. Use different colors to help you, and hopefully it should go well. See you soon.